The t-test was developed by William Seeley Gossett. He worked at the Guinness Brewery over 100 years ago, and he developed this test to determine things like the difference between barley yield. Now, he wanted to publish this statistical test to share it with other statisticians, but the brewery was nervous. They didn't want him to publish. They didn't want him to give away any secrets. He finally convinced them, but he had to publish under the pseudonym Student. So instead of this being known as the Gossett's t-test, it's known as the... So in this video, I'm going to start by conceptually showing you what the t-test is. I'll then show you how to calculate the t-value, run a t-test, and then finally, how to do a t-test in just a few seconds using a spreadsheet. So imagine I have two fields of barley, field 1 and field 2, and I want to compare them, but I don't want to cut down the whole field. I just want to do some samples. Samples from 1, samples from 2. So I could get a sample from field 1. Now, it won't be a perfect normal distribution like this. It's going to be more of a histogram that looks like that. And then I'm going to get a sample from field 2. Now, which one of these has a higher yield? Well, we could figure out the mean. We could figure out the average of each of those samples, and it looks like the average in field 2 is higher than the average in field 1. But that's only part of the picture. The mean only tells us so much, because we could have different distributions, and depending on that distribution or the variance within that sample, there could be a statistically significant difference between the two or not. And that's where the t-value comes in handy. It's really a ratio of signal to noise. Signal is going to be numbers that tell me the difference between these two samples, and noise is going to be numbers that kind of get in the way. So how do I figure out the signal? Well, the easiest way to do that is simply find the difference between the two means. And so if I calculate the mean in sample 1, we'll call that x bar 1, and x bar 2, the absolute value or the difference between the two, is going to tell you how much signal there is, how much difference there is. Now, how do we get at the noise? That's going to be in the variability of the groups themselves. And so the factor is going to look something like this. What is S1? That's the standard deviation. Remember, that's how far our data is spread from the mean. But we're not only taking the standard deviation, we're actually squaring that. That gives us something called the variance. And so if I increase the variance, that's going to lower my value. It's like giving me more noise. Now, the other factor in here is going to be the number of samples that I'm taking. As I increase the number of samples, that will actually increase the signal up to a point. And so again, the difference between the means is going to give us more signal, higher t-value, and increasing that variability is actually going to decrease it. So let me show you how to calculate that t-value. I'm using Excel, but you could use Google Sheets or even your TI calculator. So if you look at these two samples from field 1 and field 2, can you tell which one has a higher yield? It's really hard just looking at it. Is there a difference between the two, and how much is that difference? So we'll use the t-value to calculate that. First thing we have to figure out is the mean. So in a spreadsheet, you hit equals average instead of mean. I'm going to put left parentheses, and now I'm going to select that entire sample set from field 1. End parentheses, and then I'm going to get a mean of 15.38. Now I can select that and drag over, and now I get a mean of 15.68 in field 2. Next thing I have to figure out is my standard deviation, so that's equals STDEV, left parentheses. I'm now going to sample that field 1. And now I put end parentheses. So we're going to have a standard deviation of 0.3124. I'm now going to apply that into field 2's data set. So we have a higher standard deviation. Remember, I now have to calculate the variance. To do that, you have to square the standard deviation. So I'm going to select that cell and bring it to the second power. So there's my variance for field 1. And now here's my variance for field 2. And then finally, I have to know how much data I'm actually collecting. So if you hit equals count, that'll count the number of data. And so I'm going to count those, and we get 16. So we got 16, and then it's going to be 16 in the next one as well. Now you could use a spreadsheet to calculate this. You could do it by hand. It takes a long time to figure out standard deviation by hand, so I'd encourage you to use something like a spreadsheet. Now I have all these values. I'm simply going to plug it into my t-value like that. So we've got the signal on the top, so I'm going to find the difference between these two, and then I'm going to figure out my noise on the bottom. Remember, you have to divide this, add it, and then take the square root of that. So if I do the work for you, we've got a signal of 0.30, a noise of 0.13, so I've got a t-value of 2.3. What does that mean? Since it's higher than 1, that means there's more signal, there is noise. So I'm going to put that over here to the side because this video is not about the student's t-value, it's about the student's t-test. So now we're going to run a t-test. What are we testing? We're testing our null hypothesis. Just like we do in a chi-squared test, what we're going to start with is a null hypothesis that says there's no statistically significant difference between the samples. In other words, any difference that we would find is simply due to chance. You then identify a critical value, a number. If our t-value is lower than that, then we don't reject our null hypothesis. But if we get a t-value that's higher than the critical value, then we reject our null hypothesis. There must be an alternate hypothesis. There could be something going on between these two fields. Now, how do we find that critical value? We'll use a t-table that looks like this. It looks confusing, but it's really not that bad. So this would be for a two-tail test, and I'll show you what that means in just a second. The first thing you have to know is what probability are we going to use. Generally in science, we'll use the 0.05 probability. So that's going to be this column right here. What does that mean? Well, this is an inferential statistic. It means if we were to do this sample 100 times, 95 of the times we would reject the null hypothesis and only 5% we wouldn't. And so it has a lot to do with chance. So I'm going to use that 0.05. Now we have to figure out what row we're going to do. And to do that, we have to know how many samples we collected and figure out the degrees of freedom. So the degrees of freedom is going to be the samples of n1 and n2 minus 2. So since we took 16 from each, it's going to be 32 minus 2, or 30 degrees of freedom. So here's our critical value. Our critical value is going to be 2.04. So is our t-value higher than that? So this is where we're doing the actual t-test. Are we higher than 2.04? We are. And so what does that mean? We're going to reject our null hypothesis. That means there is something statistically significant between these two sample sets. Now it's not much higher than that. Remember, it's just 2.3. And if we were to look over here to the 0.025 probability, we can see that we're actually lower than that. So we're not positive, but we're pretty sure that there's something statistically significant between these two. Now that was a lot of work. We had to calculate our variance, our means, our sample size, and then find this table. The nice thing about a spreadsheet is it can calculate a t-test very quickly. So what I'm going to do is put t-test here, and then I'll just write in this next cell equals t-test. So there are 4 things I have to put in for a t-test. The first one is going to be my sample set, we'll say from field 1, so I'm going to select that. Then I put a comma in. Now I'm going to grab my data set from field 2. And then I'm going to put another comma. We're doing a two-tailed test, and this is an independent test. I'll show you what that is in just a second. But you can see in just a few seconds, we've calculated my probability, or my p-value. What is it? It is 0.026. What does that mean? It's slightly above 0.025 and somewhere in between 0.05 and 0.025. What does that mean? In just a few seconds, we're able to realize that we need to reject that null hypothesis. So it's really simple in a spreadsheet to do a t-test very quickly. Now we did an independent t-test, or an unpaired sample. What does that mean? We had 2 different fields that we were comparing. So you could be comparing, for example, 2 different populations. You can also run a paired t-test, and you would have to select that when you're running the t-test. What would that be? It's if we're sampling the same population twice. So maybe we're looking at field 2, but then we're applying a chemical and looking at it again. That would be a paired test. We're also doing a two-tailed test. And so when we're figuring out that probability of 0.05, you can think of it like this. This is the 0.95 that we would reject the null hypothesis. And that 0.05 is actually split between the 2 tails, because we're not sure which direction that variance is going to be. You could also run a one-tailed test if you're sure of the directionality, but you have to be cautious when you're running that. There are a few assumptions you have to have when you're running a t-test. Number 1, we should have a normal distribution in both the population and in the sample, but it works really well with a small sample size. We also should have similar variance in each of those samples. And then when we're looking at the data points, we should have roughly the same number of data points on either sample. And then finally, This works good with low numbers, but you generally want to be in the 20 to 30 range when we're looking for samples. If we go much higher than that, instead of using a t-test, we'd actually use a z-test. So did you learn everything I showed you? Well, now's a chance to practice it. I've got a sample set over on the left side. Imagine we have two plants from population A and B, and let's say we're looking at the leaves that each of those plants have. Is there a statistical difference between those in plant A and plant B? So you should run a t-test. I'll put a link to an Excel file down below. And then once you figure it out, what are you trying to figure out again? Do we not reject, or do we reject the null hypothesis? I'd love to know what you think. Put that in the comments down below, and I hope that was helpful.